Just to mute myself. Yes, good afternoon, everyone. I think you see my first slide now on green claims and food labels. So I will start with the webinar on what the product environmental footprint of the European Commission can mean to food companies. And I start with this slide because Europe has put forward very ambitious goals in the Green Deal, reaching climate neutrality by 2050. And it encompasses more than just climate neutrality, of course. And because of this, a lot of companies are putting labels on their food. And all these labels, there are a lot of them, and they don't always mean the same. They are not all supported by certification. There is a risk of greenwashing, and Europe wants to prevent that. And that is why Europe is developing frameworks for green claims by 2023, but also for sustainable food labels by 2024. And the framework for sustainable food labels is there to have kind of a common, harmonized way to put some kind of information on the sustainability of food front package. Now, this is the outline of my presentation. I will talk about how to calculate environmental impacts of food based on LCA, so life cycle assessment, because this is the core of what a product environmental footprint is. I'll show you some hotspots that contribute most to the impact of food, and then talk about the benefit of category rules tailored to specific product groups, because that is exactly what a PEF does. And then I also want to talk a bit about how the environmental footprinting can support food companies like you, and why transparency and collaboration throughout the food chain is so important. And I end with PEF's core in relation to food labels. But I want to emphasize that I'm not going to talk about food labels as such, so just the underlying mechanism. Okay, how do we calculate the environmental impact of food? Let's talk a bit about the world of environmental footprinting. And I always start with this question. If I ask you the question, did you have a good life? Then you would probably take your time to think about different periods in your lifetime and try to remember what it was like for you. For instance, as a child, did you feel loved? Did you feel safe? And maybe as a teenager, you had some issues, but in adult life, all went well and you found your way and whatever. So whatever your story is, your final evaluation is based on all these experiences, and you weigh them into your answer. And it means that the whole course of your life is relevant. Now, it's exactly the same when we talk about sustainability of food products. If we talk about sustainably produced food, it means that all the different stages in its production chain should be sustainable. And it also means that whatever materials are used or resources are used, they are sustainably sourced. And you see here, for instance, for the agricultural production, what is involved in inputs in a factory and what has to be sustainably produced as well to talk about a sustainable food. For instance, medicines, fertilizers, feed that is bought for the animals, land transformation that is possibly involved, and so on. And for food companies, this is also about the packages that are used, so packaging, but also all kinds of additives that are used, and so on. So there is a lot to it. Now, let me make it more explicit to you. If you have, for instance, if you make pastry with applesauce in it, then if you want to footprint the sustainability of your pastry, then you need to know about the apple sauce production as such, but of course also about the apple production, which is taking place in an orchard. And in an orchard, you use a lot of things like fertilizers, plant protection means, but also tractors, for instance. Tractors are made of metal. Metal plates are made in companies that make tractors, whatever, and metal ores are needed to make these metal plates. And so if you want to footprint your pastry, your piece of pastry, you need to start from the extraction of raw materials and go up to apple pastry production, but also, in fact, the stages that follow from there. So the use of the pastry and the possible waste that is produced by the consumers and so on, it is all assessed. So there is a lot to it. And you can panic, but I hope to explain you today that there is no need to panic. Anyway, it's a lot, but the PEF can help you. It's a real good guidance there. Now let's first talk about the problem. Why do we footprint? What is the problem? First of all, you have resources. You use a lot of resources and they are scarce. And it was already said in the beginning of the webinar, resource efficiency is very important when you want to produce environmentally friendly. On the other hand, there are a lot of emissions and waste streams that are caused, and they cause damage, like toxicity to the terrestrial environment or water environment, loss of biodiversity, ozone depletion, and so on and so on. And so what does life cycle analysis, generally speaking? It considers and quantifies in all stages of the life cycle the resources that are used, so water, land, energy, whatever. It quantifies the emissions and waste streams, and these are all kind of gaseous emissions, but also solid emissions. And it is assessing damage to three, what we call areas of protection: human health, but also ecosystem quality and resource depletion, so the stocks of resources, let's say. And it does assess the damage by quantifying impacts on all kind of environmental themes. And so I depicted the life cycle linearly, but in fact, it is not linear. It is more and more circular. And this is in line with Europe's objective for a circular bio-based economy. So in different stages, you can reuse, for instance, waste. There are shortcuts possible from the disposal phase to the resources phase. This is when material is recovered, but also to the manufacturing phase when components are recycled or even reused to the use phase. Okay, this brings me to the actual life cycle assessment and the different steps that are taken. But I want to explain very briefly the principle behind an environmental impact assessment, because I think it's the key to understand why we do all these efforts. So we can measure and evaluate environmental impact of products and processes. We consider different stages of the life cycle because we want to avoid problem shifting. You don't want to create a problem later on in the food chain or earlier. We also consider different environmental themes because we do not want to create a new environmental problem by solving another one. And we definitely want to indicate hotspots, like where, at what stages, in what processes do the highest impacts occur. Now, let's illustrate this for climate change impact or contribution to climate change, because I think that is something most of you are familiar with and we can imagine what it is. It starts with greenhouse gas emissions, and I depicted some of the main sources in agriculture. So from manure, from enteric fermentation of ruminants, from the use of tractors, diesel that is burned, and so on. And these emissions are quantified. They concentrate in the atmosphere. You can calculate that concentration, and it causes radiative forcing. This is halfway the impact trajectory. So you see, this is a cause-effect chain. The causes are to the left, the effects to the right. Halfway, we can quantify the impact to climate change. Then further on, and based on risk models, we can also assess the temperature increase that it evokes, and then the risk of species that are extinct, that will be extinct, or human life years that are lost because of climate change. Now, the more you move to the right hand side, the more uncertainty is brought into the model. And this is just for one impact category, but this is also done for all the other impact categories that you can look at, or environmental themes. And if you hear about a single score, which is used in the PEF methodology, or at least the PEF is providing a single score halfway, then what you do is you normalize and you weigh and you add up all the different impacts halfway of the different environmental themes. Okay, this slide, I go very quickly over it, but this is a summary for one specific method, the recipe method, but the environmental footprint method is very similar, where you see at the left-hand side, the life cycle inventory, or the inventory of all the resources used and emissions caused. And then it is classified into different here environmental themes. And then it is quantified, and you have impact halfway expressed in equivalence. And then you can further translate into damage to the areas of protection and even have a single score there at endpoint as well. So the 4 steps of life cycle analysis I will take you through now are goal and scope definition, inventory analysis, impact assessment, and interpretation. And what you see is there are double arrows everywhere. And that's very important because it's an iterative procedure. At any step, you can go back to the previous step and adjust. And this is done very frequently, of course. And it is also an ISO certified methodology. There are guidelines and standards, but you will hear during my talk that still a lot of questions can arise, a lot of choices to be made. So guidelines are very welcome. In the first step, and that's a very important one, is the goal and scope definition. So as a company, you really need to determine before you start, like, for whom am I doing this analysis? For what purpose? Do I want to draw an improvement path? Do I want to compare my products to a competitor's product? Do I want to design a new product and be sustainable from the start? Is it for marketing purposes and so on? And as soon as your goal is defined, the scope or the system boundaries that you set are in line with your goal. It's a very important step, but guidelines are welcome. Then the system boundaries that are in line with your goal can be a single phase of the life cycle. It really depends what you want to do. That's a gate-to-gate analysis, but it can also be from the very beginning, cradle to gate, till up to your production, for instance, or it can encompass the entire life cycle, cradle to grave. Again, depending on your goal, guidelines are welcome, like what stages do I take into account? Another important thing is the functional unit. So this is against the unit against what you weigh the impact. You can calculate the total emissions and resource use of your production, but then you still have to express it per unit of product produced, per kilogram product, per kilocalories, per 100 grams of proteins, whatever. Choices are multiple. It depends on your goal again. And it is very determinant for the result that you will show. So it's an important choice. And I give you an example here. This is a study from Trnusky. They footprinted different product groups, and the arrow is showing the fruit and vegetable group, for instance, that has the lowest impact. This is greenhouse gas impact if you express it per 100 grams of product. But if you look at the calories, then it's different. They have the highest impact. So it definitely is important. You can also use different functional units to get different insights, of course, but you have to be aware of that. And again, depending on what you want to do, are guidelines very welcome. Then there is the procedure of allocation. Allocation is about sharing the environmental burden to different products. If you have a multifunctional production process, which is very common in agro-food production, the question is which product gets which share of the burden. And so this is about useful outputs, byproducts, co-products. And we talk about an allocation key, and it means that the share is partitioned based on the economic value or a physical property, an energetic value, or a biophysical property. And again, guidelines are very welcome because, for instance, in food industry, you have a lot of residuals and they are used for energy production or for feed or for compost. And so do we need to give part of the share of our environmental impact to these users, yes or no, and what would be that share? Then what impact categories do we look at? That depends on the method, and I have displayed here the different impact categories in the product environmental footprint method. They are quite similar, but there are some small differences between methodologies. And you see that you have impact categories that are associated with the emissions. These are the top group here. And then you have categories more related to the resources use. And also here, you can guess guidelines are welcome, of course. That brings me to the second step, the life cycle inventory analysis, or the collection of data. And I will give you an example to show you what kind of data we need and how elaborate this could be. So let's say that you produce a hybrid boiled sausage. Then there are a lot of processing steps that involve the extraction of protein fraction and texturizing. You can see them here. And then after these processes, you have different ingredients that can be combined into your sausage. These ingredients are then further transformed or combined by cutting, filling, boiling, and so on. And finally, you have your boiled sausage. Now, what kind of information do we need to footprint this process? And I give you an example for one single device, in this case, the UHT. I think it's not involved in the previous process, but just as an example. So there is a use of water, most often electricity, steam, or another kind of heat source. And we need to collect data on how much is used here. Then there is other data that will tell you about the product itself, what ingredients are used, how much, and so on. And this is all inventoried, and the useful in and outputs of the process are combined, and then they are structured. They are put in terms of the functional unit, and this is the step of the data analysis. This is done then for all the different devices. So in case of our sausage, you see that we collect data from all the different devices on the one hand, but also from what infrastructure is used, because this is background data that we also need. Remember, we are footprinting from cradle to gate or to crave. Also cleaning, rinsing, whatever inputs you use for those processes need to be collected and then analyzed. And typical sources of data is, on the one hand, accountancy data or interviews. These are scope 1 data, so of the factory where you are in and the process you want to footprint. Sometimes you can make use of project results or experimental data. This is most of the time for more innovative processes. Literature, same thing. Models are used for direct emission evaluation, for instance. And then a lot of data come from databases, typically scope 2 and 3 emissions, like EcoInvent, AgriFootprint, AgriBalise, and so on. But important is that the data are as representative as possible concerning the process that you footprint, or the geographics and so on. Also quantitative and first-hand data from your company. That's important. And again, here, guidelines are very welcome, like what detail do I need for what processes and so on. Brings me to the third step, the actual impact assessment. And it involves calculation of direct and indirect effects. The direct effects correspond to scope 1 and the indirect effects to scope 2 and 3. And what formulas to use, what methods, what characterization factors, midpoint or endpoint, single score, whatever. Again, you see you need a lot of guidelines. Indirect effects come from databases, and what you see here is you have a product, you look it up in the database. Believe me, it's a lot of work to find the representative process. And then you get all kinds of characterization factors. Here you see the different environmental themes, and then the equivalents here expressed in numbers. That's how it works. And for the direct effects, you start with calculating emission factors or emissions. Usually or typically a lot of formulas are involved. Then you have the amount of emissions, and I give you some examples from agriculture here. They are classified into impact categories they contribute to. So for instance, ammonia contributes to terrestrial acidification, but also eutrophication. Then you have the characterization factor that expresses it in a single unit per impact category. So climate change is in CO2 equivalents and so on. It is then added up to get an impact midpoint, and this is a first evaluation midpoint. For instance, here, the CO2 equivalents, the sum is the carbon footprint as we know it. And then further on, you can further characterize into damage to human health, ecosystem quality, and resource depletion. And this is done for the entire process. And here you see again the different choices that have to be made and for which guidelines are welcome. And let me give you one example of a footprint of a process. You see here that it is in relative contribution of different in different impact categories. So climate change up to ecotoxicity of fresh water. I just depicted a few of them. And on the other hand, you see the different life cycle stages that are colored in the different impacts. And this is kind of information that you can get from a footprint. So it gives you a lot of insight as a company. It brings us to the fourth step, interpretation. What does it mean? You get a footprint like this, but what does it mean? It would be nice to compare it to similar products to know about the validity. How certain is this result? And especially for new processes, this can be kind of a tough step because you don't know what to compare it to and so on. So especially here, guidelines are welcome, but also benchmarks are welcome. And this brings me to the second section, but believe me, this was the longest section, of course. It was the most informative section. I want to give you a quick view on the hotspots that contribute most to food environmental impact. And you have probably seen this graph before. These are two studies, but they show actually the same. Two very comprehensive studies of the food system, one by Poor and Nemecek, 2018, the other one by Kripa et al., 2021. The difference is that Kripa also includes non-food commodities. So you see that the impact of the agricultural stage is a bit bigger because cotton, for instance, is also footprinted and so on. Now, this is a worldwide impact. So all products are in there from worldwide production. They have different system boundaries. The one is including the use and the waste stages. The other one is not. And you see that the primary production is dominant in general in food products. But hotspots are product dependent. And I will quickly show you that. But first, I give you percentages of the same figures. I think this is probably more understandable than the absolute numbers. And both, in fact, have the same conclusion. The food processing is taking up 70% of the footprint in both cases. Only in the Kripa study, also the use stage and the waste stages are included, and so they add another 12% in the total. So you get the big numbers. Now, I said that it is different depending on the type of product. Where do these differences come from? What you see here are 3 examples of animal products, and you see that a lot of impact here. This is about the greenhouse gas impact. It's not all environmental themes, it's climate change that I focus on now. Is in the farm stage. Why? Because you have a lot of emissions from manure, from enteric fermentation, and so on, typical for animal products. They have a very high global potential, global warming potential, and so they are very dominant. Now let's look at plant-based products. There it's a bit different. And again, depending on the processes that are following the farm stage, you have a higher or lower contribution. Remark that for soybeans, tofu based on soybeans, the processing step is taking up more of the impact, but it is because this is not absolute, of course. This is just percentage-wise. And it is because soybeans do not need fertilization on the field, so you have far less losses in the farm stage. And then a third example is where the footprint is mainly, or the carbon footprint, I should say, is mainly dominated by the processing, packaging, and distribution stages. And this is for more processed products. So it is wise to have your own footprint and know where the focus should be. Then the benefit of the category rules, I think I've mentioned it before. Wherever I said guidelines are welcome, you get guidelines when you use product environmental footprint category rules, because they have, you see here, specific guidelines how to perform such an assessment, what stages to include, what methodologies to use, what data to use, and it's harmonized. This is just to show you that the entire process started in 2014. The environmental footprint methodology is the basis. We have guidelines for products, but also for organizations. And since then, a lot of reports have been published, a lot of updates have been published whenever the method is adjusted or inventories are refined, with the latest one in 21. And for the agro-foods, the current category rules involve dairy, beer, feed for food-producing animals, and then this one is not official yet, but it's towards a footprint for horticultural products. But nevertheless, you have the environmental footprint methodology as such, so you can start footprinting for all kind of products. What is in such a category rule? I don't know if it's clear because I realize it's small, but you have, for instance, representative products, functional units, system boundaries, information or guidelines about those. Also guidelines about the most relevant impact categories, a list of mandatory company-specific data. So these are the kind of details you can find in the guidelines, but also allocation rules at the dairy farm, at the dairy processing, how to model electricity, because it's difficult sometimes if you have a company with different processes, also different products from the same device, how to allocate electricity. And so you get guidelines for all of that. On the other hand, you also have benchmark values. In this case, for liquid milk, but also for fermented milk and all other types of products. So it's very informative. And how can environmental footprinting support food companies? At least you get insight where to improve and also insight on the actual improvements if you footprint again. You can communicate about improvements. And I'll show you if you, for instance, halve your water use. I don't know, the purple one should not be there in the beginning. If you halve your water use, you see that the water footprint or the footprint of water use here, the gray, what is it called? Beam, it's not beam, bar. The gray bar is halved, okay? So the impact is half of what it was. If you take energy efficiency measures, then you also reduce, for instance, the fossil resource depletion category. If you work on renewable energy use, you will even more reduce that one. And if you work on reducing waste losses, then you have an impact in all categories because it has to do with the functional unit. You have more products or useful products from your process. And so your impact will overall be lower. Then transparency and collaboration throughout the food chain is very important. Why is it? Because of course you need data from the companies that deliver to you, or you need to deliver your data to the next step in the production chain to have a final footprint of the product. And it is important to know that you do not share your insights, but you just share your relative scores because you express it per functional unit. And for instance, here, the farm stage farmers can give their footprint of their products and give it to the food processing companies. They add their own footprint. And so you have equivalence per functional unit, new equivalence per functional unit. The same is occurring when the retail is adding their part of the footprint. And then you can still add some more parts, for instance, of the use stage that is modeled, of course, and the waste stage. And in the end, you have, if you weigh it into a single score, you can also have one single score in millipoints per functional unit, or you can keep the different impact categories and the equivalence per functional unit there. How can it be done in a reliable way? How do we do it already for instance, milk production? We use a data sharing platform, Just Connect. It is a Belgian platform for farmers and their data. You have the link in the bottom right corner there. If you have questions about it, please contact us because it's very important. This is the way, for instance, how dairy farmers share their footprint with the dairy firms. And then I'm almost to the end of my presentation. What is the PEF score in relation to food labels? Very briefly, because I think it's important for you. The PEF single score, where you actually combine all the different environmental themes, is the basis for instance, the planet score and the eco score that are already that you already know. Primary data of ingredients are often taken from databases. So food companies do not know the footprint of their farmers, and so they take it from databases. For instance, Agribalis, a French database, but we know that there are quite some differences depending on the agricultural product that you footprint between these general data or data from France, from Germany, from Switzerland, and our data. So is the true sustainability of Flanders agri-food products reflected? No, if you use data from databases, it's not. It will tell you quite some things, but it's not extra representative. In the next step, the single score is log transformed. So at least this is the case for the ego score. And there are no absolute differences in impact. We can understand that because otherwise you cannot put different products on the same scale, of course, because as you know, animal products will have a very high score compared to plant-based products, but it is not absolute difference that you see. And if you're very interested about these labeling, then there is a webinar in 2 days on Wednesday. It is organized by the Dutch Ministry of Agriculture. And I was free to share that information with you. And if you want to attend that webinar, you can contact Janneke van der Veen. That's her email. So you can definitely tell her that you heard about the webinar and she can provide you with a link. And finally, how can we support you? As Karen already said, it all starts with a question. So please contact us. We are keen to help you out here. And yeah, I think that is the last slide I have to share with you.